Your Excellencies, ladies and gentlemen, welcome to the first technical session, which will showcase innovations for developing a more intelligent and efficient geological exploration. The session will present the experience of improving the reliability of the results of geological research using the latest airborne geophysical technologies.
Ваше превосходительство, дамы и господа, добро пожаловать на первую техническую сессию, на которой будут представлены инновации для развития более интеллектуальной и эффективной геологоразведки. На сессии будут представлен опыт повышения достоверности результатов геолого-технологических исследований с использованием новейших аэрогеофизических технологий.
Hello everyone again. Thank you for coming back from the lodge. Can I ask to come closer? Can you sit please closer? So don't be afraid. It's not me to present or make presentations. We agreed to place our speakers in front, not to close the screen, to make it open. And now I will announce and invite one by one the speakers. Pavel Babayan, who represents Aerogeophysica. Ivan Kozarev, AGT Systems Vostok. Kirill Bazhin, Geo Evidence Kazakhstan. Eric Kanaev, Geo Support, please come closer. And Emil Churmukov, who will represent SEAL Company. Pavel. Please, Pavel. Thank you and good day, dear ladies and gentlemen. Same as others, I would like to thank the organizers for this excellent forum and the opportunity to share my presentation with you in our first technical session. The company I represent is the Geophysics State Research and Production Enterprise. Aerogeophysica is a leading Russian company performing complex airborne geophysical work for a wide range of purposes, both in Russia and abroad. When performing work, we use most advanced hardware and software solutions, technologies for complex interpretation of the received data. On the map, you can see the Russian map with the airborne methods or research methods. We have solid experience. We also have experience working in both neighboring countries and far countries. However, not all the types of works are represented given the scale of the map. So we have also detailed maps in possession of mining companies to explore and assess the minerals deposits. The companies in geophysics have two ways of work, or two types of specialization. One is with excellent airborne technologies apply, others engage other specialists or experts to have a wider picture of geophysics of the site. So we decided our company focuses on complex issues by applying machines, by improving sensitivity, by increasing the weight, and improving and decreasing the technological conflicts, noise levels, and so on. A few words about our magnetometer, so-called magnetometry, can be used on traditional drones. It can have 4 detectors on one channel. It can be used also on drones, and provides a new assessment of ingredients of magnetic belt. Next one is a gamma spectrometry, in-house produced spectrometer with a variable detector volume, NL detector units with the TI resolution 59%, volume from 8 to 48 liters, and for separate spectrum registration 1 second for drones, or when used with drones. And this is our pride, I would say, gravimetry without platformless, so-called. Gravimetry is the strap-down airborne gravimeter HV graph system. Main characteristics: it has a power consumption 150 watts. We can have an accelerometer range with plus minus 20 grams, and gyroscope stability and accelerometer stability can be used traditionally with other elements, with drones, to explore minerals. The key methods: we have 2 areas as a frequency system, so-called, to be used on helicopters, aircrafts, or hanging with generator loop, which can be used from helicopters as it goes, or Eurocopter as it goes, and impulse systems, in-house technologies, which can be set the parameters of geophysical breakdown based on physics and math modeling, and Earth surveillance by flying above the Earth, calibrating the parameters as to have better imagery. This is how the system looks like. Horizon, you can see the geometry and parameters or characteristics of the equipment, and you can see the generator loop fixed on the helicopter. The experience showed that it's not that have shortages, or sometimes even better than Western elements or Western equipment by different characteristics. Additionally, different types can be used, such as for the imagery, so-called, or aerial photography and airborne laser scanning. So notion of all those developments is that technical parameters of this equipment will enable to set all measurements on one equipment and have information from one flight. This is the machine we're working on. My enterprise, talking about the approaches in forming the set. Today we can observe the systematic decrease in exploration. It is obvious that most deposits were explored already close to subsurface, at least in Russia and Central Asia. So geological exploration is better, of course, and it is noteworthy that to move from a strategy aimed at directly identifying an object anomaly, to predicting exploration conditions using the full range of modern data analysis and technologies failing now. It means we have to shift by direct exploration of a first object towards using an entire spectrum of geological data in both retrospective and obtained data. The strategy provides the following sequencing the factors of localization of a target object. It can be achieved if we use geophysical conditions of the Earth. It's not a condition, it's a requirement. Depending on the object, the range of the object, let's say target object is the ore deposit, site, nude, can radically change those factors of localization. It means that it's not enough to make aerospatial data to obtain, but also we have to be able to appropriately analyze this data. with modeling and focusing on localization typical or factors typical to that object. We have such assets. So that means we apply different softwares developed in-house by applying the best analytical, both Russian and foreign developers. This is the example. Object, what's the slide though? Which fly, I would say, is a set of airborne, so-called geological exploration, gamma spectrum, and optionally you can also the laser scanning option. Second was impulse or impulsive exploration, a domain, as it said in the international literature, Western literature. If aircraft, let's say, or helicopter needs a laser scanning equipment, the loop or generator loop can follow the aircraft. Examples.
So a full complex is applied, for example, western slope of Ural Mountains, 1 to 50,000 scale survey as a part of geological survey works. In fact, in our history, this type of survey was done with the flying over the objects, so with the necessary binding, so gravimeter, gravitational field with aerial survey was combined to create mapping of tectonics. In fact, this gravitational tectonics is mapped better than with sounding or regular type of survey. Gravimetric data compared with on land data collected in the territory of Russia, Kazakhstan, Uzbekistan, Kyrgyzstan. I think it's a state survey that was conducted at 200,000. Materials are available. We compared our work with these results, and this volume modeling of gravitational field with a vertical cross-section on the right. It shows how well gravimetric data allow to map steeply depositing depositions, overthrusting parts of the rock mass, and data collected through gravimetric survey appear to be better than just on lead survey. Charasin area, South Yakutia. This is one 25,000 scale survey with the purpose of geophysical mapping and evaluation through geophysical methods of prospective for manganese or gold and diamonds or gold. Here the comprehensive magnetic sounding survey that allows to reveal rock mass carrier of the Lebedensky type deposit, showing permissible. Speaking about isometric type intrusions, that shows that Lebedinsky type deposition. If we talk hypergenic processes in upper type of the cross section, because there could be some kind of karst formations at all. This is coronar type deposition of ore deposits. So speaking about the mapping of factor of localization of ore formation that allow direct access to the purpose object. This search of hydrogenic search of uranium deposits, and this classification called sandstones and other type of rock deposit. 50,000, 10,000 detailization of the mapping with erosion depressions mapped with this type of complex, and shows the delineation of those bodies. So there are paleo depressions where uranium is deposited or sedimented, and within sandstones, that's where uranium deposition is attributed to. So this is ore gold based on spectral processing, and gamma spectrometry is reflected in average scaled ore manifestation, and gold ore formation at the north east part. This is another survey of grade 2000. This is geophysics, electromagnetic scanning, laser sounding, and aerial survey. Orthophoto plants type of greening type of growing. Here we talk about different type of cultural deposits. Impulse survey shows parameters of polarization, not only conductivity, and results of conductivity show prospective sites, objects with higher electric conductivity next to the contact vulcanites with a higher magnetic perception. So magnetic survey plus electric survey allowed to find the object. This is the search of copper nickel ores, which are well seen at geoelectric cross sections. So conclusions that could be done based on this: the complex or comprehensive geophysics is improving our reliability of search and exploration tasks. And what is important when studying objects with what we call blind manifestation, with regular methods, they're not accessible unless you talk about drilling. So new equipment and technical solutions are allowed to use this full comprehensive complex approach combined in one air carrier, which is important, and the survey at the same time. So this also allowed to improve investment attractiveness of certain exploration areas, which could be of interest for the companies and state authorities doing geological survey and exploration. In difference from our Western colleagues, we not only provide the service itself, but also a full set, like including equipment, software, hardware, and training. Thank you. Thank you, Pavel. Actually, I would like to remind you that you can write down your questions on a note or just memorize them. We will get back to this after. So next speech about Ivan Kozarev, AGT Systems, Vostok. Vostok means east. Good afternoon. Thank you for coming. Bishkek, thank you. Organizers, thank you. I present a family of AGT systems companies. We work for more than 20 years in the area of supply of contemporary geophysical technologies at the market of Central Asia, Russia, and whenever they call us. Up-to-date technologies are not only inventing new methods, but this is also about improving old good ones, and with the use of contemporary technologies, such as drones or unmanned flying units that has become, if not revolution, but a great step forward to improve quality of work, especially for small companies that cannot allow big aerophysical complex to be used. Our findings, and we collect all over the world. And last year we were visiting China to see what was suggested by our Chinese colleagues. And currently, I would like to give an overview of technologies as that we believe are relevant and could be in demand for geological exploration work. Unmanned technologies and magnetometry, what we call magnetometrics, is already MacArrow is one of the geometrics leader at the market, and recently, less than a year ago, they have published second version of MacArrow magnetometer. It is differs with its light weight and simplicity of use. It has only one button. Everything is inside, hidden. Doesn't require any additional connection. It's just hanged on a DJI standard drone, and give the flight task and just flies automatically. The technology allows to decrease costs for survey compared to the walking routes, for example, especially in the hard-to-reach areas. And a year and a half ago, my colleague Alexander Luchnikov have participated in such works where on top of the walking distances. You see the green area, that was a walking magnetometric survey, and blue box was Mac Arrow drone flights over the territory to compare and see how these data match with the traditional survey made on foot. And in fact, practically almost in full, it's fully coincides, especially if there is a difficult terrain. In fact, drone use is even better in this regard. Same type of approach is spectrometry with the drone develops. This is Medusa company from Netherlands. They produce spectrometers of different size with a different size of crystal for different drones. And also everything is fixed in one body, in one block, and works fully automated. And this is very attractive for many companies because, for complex devices, quite often it is required to have a specially trained staff that has been trained for a long time. And here, producer focuses on simplicity of dealing with such devices, which actually can be like plug-and-play device, just can be used instantly. I won't focus on description of every type of flying device and different type of units, but generally their use is getting more and more advanced, especially speaking about LiDARs. I think one of the leaders in production is, of course, China, as to the types and sizes, and they have quite good developments with now with a good software to make sure that, and this is very important for LiDAR because to build a proper, a route and within given time, and that allows to do it well for LiDAR. But of course, traditional survey does disappear. So for many years, radiation solutions from Canada is providing one of the leading solutions for HAMA spectrometers. They have both aviation type use for a walking route. Here we have field spectrometry tools, which is often done with in the field, which is like a attributive or additional survey that could be done by a field geologist who are simply walking on routes. It could be done both with accumulation of data statisticals per tags or per points, or it could be uninterrupted type of survey. Electric survey. I won't focus again on the details, but I would like to tell you the technologies developed. We recommend ACCOS, GDD. Those producers have already proven they have different type of equipment for different types of electric surveys for different tasks. Gravimetrics. In the world, not too many producers of gravimeters available now in the world, but most popular models are Syntrex company models, and a couple of years ago, I don't remember exactly which year, but it was CG6 was produced. In fact, on the one hand, same technology, a sensor is the same, but through different electronics and its changes and update and new technologies, mass of the gravimeter have decreased, speed of processing have increased, and speed of survey, automatic corrections for different type of variations, including sun and moon cycles. So that is now more reliable, I would say. Also, they have slightly changed interface, and almost any person you show one time, and person may be left to go on the route. So the most important thing, not to hit it strong above on the rocks, but other than that, it just works. Software for processing of geological data and geophysical data. You probably know that Oasis montage package. Many of you worked on that. Last year in China, we managed to visit Horin company. Horin. And we found out that they have similar package to similar to Oasis montage package. I think they were inspired by this package, but they develop own software, and there is a big substantial difference in their Horin software, because they have a good package on processing geophysical data, in fact up to 3D modeling. That's quite a difference. But on the other hand, they don't have inversion options for gravimagnetic data. And of course, standard package from Oasis montage that grew up to the condition that actually now allows to merge geological and geophysical data, which is quite helpful in interpretation when everything comes in one place. And in general, this package does have a very good tools and instruments to work with large databases, allowing to bring all databases in one window. That really simplifies and speeds up interpretation, the final one. Another finding in China was the passive seismic survey, wireless seismic. They position themselves as engineering equipment, but in fact they have certain cases and works in defining different type of cavities, karst cavities, and usage in seismic surveys. So the difference of the seismic meters is that they share data through 4G and 5G networks. I mean, if you are in where it is possible, which such infrastructure is available, then you could right away at your computer or your pad, you can see just results of such survey in a real-time mode, actually, and in the process. And it was quite surprising to us. We didn't trust it at the beginning, but the cost of this all seismic set was much cheaper than Western analogs, but quality doesn't leave much thinking about that. That was really good one. If someone here is interested or elsewhere is interested, so producers asked us to share this knowledge, and they are ready to come, show, and share and demonstrate how these equipment works right on your facility, your objects and deposits. After a survey, geophysical survey, our next one is common geological exploration with drilling. We had experience in Kazakhstan, and that drilling rig, Hydra core, was supplied. But that was a situation when it was not possible to deliver it by road. There was no road. But Hydra core, they have a model that it actually split in several parts and could be dropped with 2 trips of Mi-8 helicopter, just dropped in one place, put together with these 2 parts come together, and drilling is done in the hard-to-reach area. And that drilling rigs showed its effectiveness. After drilling, all necessary information need to be extracted from those wells. And I think there is nothing better than Karotas from ALT company. This is Luxembourg, and Mount Press of United States, MSI. So this is in the borehole surveys, sounding and the full technical support of these devices. And what is important, quick repair and quick replacement of pots or sounds or sounding emitters for replacement, which is actually very important apart from accurateness of the study. And everything that everyone loved in Russia, and many companies have related that in Kazakhstan, there's a televiewer. In fact, that actually shows video, footage from inside the drilling, the boreholes that actually allow to physically see the fractures of the fracture type of rocks, see the veins and veinlets. The company is using it for monitoring of fractures after blasting. So they would put an acoustic device at the carrier, so bench or the wall. And then after blasting or explosion, they would put it down and see what dynamics was there. So we have limited time to speak about that, but acoustic televiewer actually allows to simpler and quicker interpret data and actually plan further drilling. If we have good understanding where the layer actual dipping, where it goes, which structure is located and what type, and that allows to physically see it. And also a whale cat version 5.7 was published this year. It is like just a window solution, like Windows with drag and drop items, and allowed to see all the in the borehole information to be processed at a very high level. Our task, we position ourselves as a company that helps, actually analyzes the tasks that have been set by the company and selects the right solution for this particular task, including equipment, find equipment, deliveries, conducts training, makes it operational, and ensures good connection between the producer and the customer. That's it. Thank you very much.
Thank you. Let us continue the topic of geophysics. Mr. Kirill Vazhin, please. Good day, dear colleagues. I represent the Geo device. We produce equipment and software. In my presentation, I'll talk about what we produce in generally.
Okay, we provide different types of surveys, including sea and on-land magnetometrics, and we also develop aeromagnetometers and walking magnetometers for various types of physical survey and for radioactive survey devices. We develop, as I noted, walking magnetometers on land and different type of stations, and set aeromagnetometers and sea magnetometers. So there's the on the slide you can see examples of our products. One of the most top products is actually walking magnetometer called Maxi Mac and Quantum Mac. They use different sensors. Sensors on Overhauser effect meter is used, and granitometer with quantum sensor is used on the other one. We create everything, the system, all type of set the way you fix it on the body, and download of the data and all necessary device. So we produce magnetometers and gravitometers that could be connected to several meters, and each gravitometer can be used in different conditions. It could be for walking survey, that could be installed as a automatic reading station. All magnetometers might be connected to each other, they're compatible, and if you have a walking sensor and the station, you may actually do the collection of one gravitometer. And now you see the control panel that is attachable to any of our sensors. Any number of sensors could be connected, usually 2, 3, 4 sensors connected to one control point. We also have two-size keyboard. If one hand just gets frozen, you can use the other one on the it's a cockpit. Plus we have heated screen and actual lighter if you too late in the field, and actually you can upload it to iPhone or Android type smartphone anytime. The slide shows our compact type of on-land magnetometer, which we recommend for the use as a observatory. It just actually can be fit in the hand luggage in the airplane. It can be actually physically carried with you on a backpack or rucksack. And this sensor has a lithium-ion battery blocks for data storage and transportation, and also it could be used with a basic GNSS station, and this data could be processed for high precision geotagging of your data. Recently we have developed a software called Smart Manager for control of the data collected from magnetic survey stations, and actually this device could actually allow to send you data that data are not collected, or there is magnetic storm, or some kind of outage there. So my colleagues in the beginning noted that you don't have to fly over that, but you can just use it very effectively. This is a quantum version of a magnetic station, just looks slightly different. It has additional blocks. For geophysical sounding and survey. Aeromagnetometer was recently made as Overhauser effect use magnetometer. This is not typical for use in aero type of surveying, but we decided to go test it, and this is a good way to high gradient environment to conduct survey very quickly and at low cost. And this gravitometer win on cost, but slightly slower in terms of speed, but they provide good results. Here you can see comparison of our two aeromagnetometer data with Overhauser effect and with a quantum sensor. Some sensitivity is different and some speed of measuring is somewhat different. Since we produce it ourselves, we test our devices ourselves, we improve them, and we also collect feedback from our partners, and we're quite flexible. Here, the data collected from quantum magnetometer and Overhauser type sphere. So the structure of the field is very similar. Of course, there are somewhat minor differences in a detailed study of this mapping. We also developed C magnetometers. This system of 1 meter, we have longitudinal and latitudinal cross-sectional type of meters. So we do it in the seas and in water objects. These are radioactive study, actually, so field walking radiometers, and also that radiometer is put in the boreholes, so to check it inside the wells. We also do for vertical seismic and profiling and actual cross-sectional registration between the boreholes. There's a different type of registration, hydrophone, geophone, type of collector and accumulators of energy devices. So this is in borehole equipment that we produce, including the winches, motorized winches and manual winches that could be used to do the measurement inside the boreholes. Now, sea equipment, we have electric survey for electric tomography in seas, so the whole set of equipment. We also produce full set of equipment for sea high accuracy resolution and seismic survey, electrodynamics, sparkers, boomers, accumulators of energy, registrations, and different type of other devices, plus auxiliary equipment. We produce ourselves and we supply the full set. Of course, we cannot produce everything, absolutely, so we do cooperate with world producers such as GDD, which actually makes first-class equipment for in-depth magnetic survey, electrotomography for studying so rock sample, and our partner is GCS company, also, which is producing software for planning of flight tasks. And we use this software to when we test our magnetometers with drones, and they have onboard computer where drones could be connected to different sensors, including geo radars, gas detector, sample collectors, devices, and many other things. Could be. Our partner is a Czech producer of electric survey equipment, of different type of generators for electric tomography stations. We're actually very good in collecting data on ores. And our long-lasting friend is MINEX Geophysics, one of the world leaders in producing tellurium magnetic stations. I think they are the best one in the world in this area. Our company has offices, production office in Kazakhstan. We're presented in Europe and in Canada, and we have representations all globally. Let's few photographs from our life, because apart from just producing devices, we do testing, launch equipment, we train students, we do practical exercise in Kazakhstan universities, and we'll be happy to come to Kyrgyzstan for a couple of days, show contemporary equipment, and share the knowledge. Thank you very much for your attention.
Thank you, Kirill. Yes, we have technical session, not only geophysical session. So let us have a dissolution from other disciplines. So let me invite Mr. Eric, who will talk about GeoSupport. I represent a young startup company established by experts who have been working, let's say, in large companies of geotechnical equipment production. We have several areas of our operations. First are called the INSAR monitoring system. You can see our production line of equipment. We, as I said, the monitoring including long-term retrospective analysis, technical support and maintenance of ground-based geotechnical radars from various manufacturers, and exclusive distribution of the latest interferometric geotechnical radars, Chonaf, China. We apply different strategic backgrounds, so for retrospective analysis of the satellite imagery monitoring is better, is cheaper, available in open data or resources. So the only question is how to interpret those data. For ground operational monitoring, let's say, it's better to use the geotechnical radars. Why georadars are better? Accuracy is very high at the sub-millimeters. Depending on the distance where we place the radar, we will have a pixels and sizes. Mainly, most radars can survey or shoot up to 5 km, and by coverage, it is 360 degrees. In practice, I never faced a case when radar can shoot with a 360 degree to have very accurate, reliable data. Why do we need to perform monitoring or to monitor through radars? Or of course, first of all, is the stability in real time allows you to answer the following questions. When we have to control the risks and to evacuate equipment and people in case of an emergency. As for geotechnical risks management, I can divide by type of risks. We have two types of risks. First is the tracking of critical risks when we know a disaster or the emergency area, and there is a need to control the works in this particular zone. For instance, an accident took place in the history of humanity, let's say in Bingham Canyon. If you remember, in the Bingham Canyon in 2013, the most massive collapse in history, as I said, more than 165 million tons of rock fell during the landslide. And with the help of radars, it was possible to bring personnel and equipment to safety in a timely manner. It helped minimizing human fatalities and to minimize the damage. Second is of geotechnical survey or should the possibility of evacuation of rock in dangerous areas or with difficult or harsh technical conditions of the earth, let's say. So to better explore the ore with high-risk zones. And by simply installing a radar or small equipment, you can control the situation. As for the application of geotechnical monitoring, first we have to look at the limitations and costs in higher than other devices, hydrogeology or the exploitation levels of the pit and so on. Different types of germ monitoring can be used. You can apply also other tools, not only to buy a new radar, of course. On the next slide, you can see a comparison. When we use radar and radar, so-called the total station, tachymeter, in other words, to get accurate data in radars and so on. All data we obtain through geotechnical radars, they represent in the graphics or diagrams of deformations, speed or backspeed, and so on. Depending on the parameters of the diagrams, our expert or any experts in geology or geotechnical experts can interpret this data and can decide, control active deformations, and again to decide or make decisions to stop, on hold, or to perform other activities. Few words about the geotechnical radar, CHCNAF. We've been cooperating for 2 years with the Chinese-based company, CHCNAF. However, due to geopolitical changes in the world, we had to explore more about other 3 top companies in this regard. We have later found 3 companies in China focusing on geotechnical radars, and through our help now they are gaining access to international market. The company is quite big, is in the top companies in geophysical and innovative devices. The radar, this is one of the models of this company, which is very optimal in terms of cost benefit and technical characteristics. The coverage has, as I mentioned, on the 360. As you can see, the characteristics, for instance, the azimuth cover 360 meters, elevation is 60 degrees, and azimuth resolution is 5 mRad. Scan range is about 5 km, as you see, and the scan speed, if we set azimuth 180 degrees, in 30 seconds it scans the entire pit, the area. In comparison with Western analogs, we have very simple radar in 2 cases, can be transported with a weight of 25 kilo each case. We rarely supply in a set or assembled manner of the device unless you plan it to have it in station. It's up to you, but we always recommend to use a mobile type, so the version of this device. Locally, we use a chassis and equipped with other energy devices and so on. You can see the main device is on the wheel with autonomous electric feeding and operation of the radar. The software is translated into Russian. It's not a challenge or the problem to translate into other languages. Depending on the customer, we translate in a very quick manner. Thanks to our Chinese partners, developers, they always meet our requirements. In CIS countries, we have successfully implemented those radars in Russia. There are several radars, but here I would like to show you some case studies where we have tested them and implemented and introduced. Krasnoyarsky Krai, in one of the regions in Russia, we have tested on a large gold deposit at the site. In harsh weather temperatures and cold weather in winter, and how will it operate, and to test it, to compare with other Western analogs, similar devices. Tests showed that data obtained from radars, we have compared them with real aperture data, and you can see the graphics and diagrams are almost overlapping, so the radar performs the same functions as Western analogs. In other words, it meets the goals. Noise or different trends are almost similar. We have placed the radars together with two analogs, Chinese manufactured and Western analog, and you can see the sizes of pixels. The Western analog was 74 square meters, and our Chinese analog, the pixel size was 1.5 square meter, which is a good indicator. You can find additional publications if you want to in our magazines published. If you are interested, you can read it out yourselves. You can find additional information here. Another case study was performed in Kuzbas, one of the Russian regions, on coal. We all know that in terms of coal, we have even more challenges. Given the specifics of coal ore is different, and mine deposit, as you can see, is different with different angles, not perpendicular. Tests were also successful. Radars shown good outcomes with correlated graphics. Similar tests were performed in other places and compared with other companies' radars with different amplitude of signals. And the graphics were almost similar. He's comparing different analogs with this Chinese manufactured device. After tests, we witnessed the devices were operating successfully, and we have started supplying to the Russian market in Kuzbas, Far East region of Russia. So we have about 9 radars are now being used. We receive data, we provide our help to customers in terms of maintenance, and indeed, technologies, or let's say hardware shows no challenges or problems. It is operational. So this is the end of my presentation, colleagues. It's a really long presentation, so you can learn later. So we will be a bit late because we started late. Let us have one more presentation, and we will let you go to drink coffee.
Emil Chernakov will make his presentation. Okay, I would like to give you brief information about the services provided by our lab. for mining sector of the countries of Central Asia. First of all, I would like to watch a short video about our laboratory. A testing lab, the Stewart Assay and Environmental Laboratories, is an independent analytical laboratory. Opening took place in August 1997. More than 27 years at the market of geological services. Main areas are technical testing, preparation, sample preparation, geochemical assays, analysis of environmental assays, and metallurgical testing and inspections. Clients are geological exploration and mining companies working not only in Kyrgyzstan but in Kazakhstan, Tajikistan, and Uzbekistan. Laboratory is located in the territory of Kyrgyzstan and the Karabalta city, 60 kilometers west from Bishkek capital. They have accreditation and to meet international standard ISO 17025 and 17020 and UCAS Center from UK as well. It has its own accreditation system of LIMS, Laboratory Information Systems. Laboratory Information System allows to cover all processes of the lab, get data through internet by the clients, and integrate own systems. Production Donaldson, FL Smith, Rock Labs, Morgan, Sartorius, Medlar Toledo, and Agilent, Perkin Elman, and other companies' equipment is used in the assay. So the level of the lab allows to be competitive with different labs, providing a geochemical analysis, fire assay of gold, platinum, and palladium. Testing also precious metal with the composition of Tsar vodka solution, which is composition of sulfuric and of acids, analysis of geological for acid decomposition with a lithium mass spectrometer and seductive connected to the Perkin, Elmer, and Agilent type of equipment, to the fire acid, classical chemistry of environmental analysis, including treated water, sediments, sediments, filters, sediments, and other type of samples. Contemporary technologies of measurements are used, as well as traditional and newest technologies that allow to decrease costs. X-ray fluorescent analysis, RPA, that allows to find elements from beryllium to uranium. With the help of express or rapid survey, Neton allows to save funds and get results quickly. Geotechnical tests done on cyaniding and bottle text, flotation, and gravitational enrichment processes, HIP leaching, and accreditation on the national standard 17020 allows company to deal with pre and post load inspection, sample selection. There are good conditions to work with the samples which arrive before and after the testing, ensure condition and the environment protection. In addition to this video, I would like to give you brief information and comments to what you have seen. The lab is currently operating, as it has been mentioned in the video, for 27 years. By now, it is located in Karabalta city at the crossroad of main roads connecting Kyrgyz territories and countries of Central Asia. We're talking about roads east-west from Kazakhstan going through Kyrgyzstan to Uzbekistan, and north-south road, which is going from the north to the south of the country, of the Kyrgyzstan and to Tajikistan. So location of the lab was selected in terms of logistics of supplied samples for analysis. A lab is using different methods of for analysis. The main method of analysis is geochemical analysis, so geochemical sample analysis. Our methods are based on international standards such as ISO, EU norms, ISTM, and organization norms. Lab is participating in various comparative samples and check testing, such as Gerta comment. And lab also participates in certification of samples that confirm our competency as well. As video noted, lab has a LIMS, LIMS system, Laboratory Information Management System. I would like to talk briefly about peculiarities, because major the lab is using such system for many years, and this system is used by our partners companies, Archimed Technologies companies, and based on our task, and speaking about that was prepared for our conditions and for our request. And as our lab system develops, LIMS is also improving in expense and getting modernized. As LIMS system, this allows to track samples throughout. The lab allows to use barcodes for better identification of various objects, starting from the samples actually to equipment of various types, and also allows for safe movement of and transfer of information that actually collected right from the weights and information from analyzers, and actual sharing this data with the customers. LIMS provides a reliable system of access to such information, of course with different rights of access by various groups of users. It actually automates quality control system, generates reports, allows access to these reports from the customers, shares information about the status of works being accomplished, and the main goal of the LIMS, again, decrease the risk of error in performing routine tasks. Apart from geochemical analysis, lab is performing the following types of work. First of all, analysis of samples collected from the environment, so ecological, such water, soil, samples of active mining companies collected for monitoring of environment. Another additional analysis are technological testing analysis. Lab is performing original metallurgical testing to evaluate amount of metal to be extracted, or extraction of a metal through such as cyanide leaching in certain bottles, in columns, and flotational enrichment and gravitational enrichment as well, so as part of the equipment. So I apologize for this. Lab provides services for inspections. Our inspection department specialists may come to any mining company, usually extraction plants, enrichment facilities, where our specialists may evaluate the quality and quantity of received or of loaded and sent commodity, which is ore, concentrates, metals of put in metal bars, cathodes, and different type of facilities. So before this additional works, apart from the geological, in addition to the geological analysis and testing, allows us to fully cover and give a wider range of services to mining sector companies. In fact, we do tracking of all life cycle of mining company, tracking from the early geological exploration to mine closure and recultivation. The lab is equipped with up-to-date and contemporary equipment. Okay, thank you. I need to speed up. That preparation lab, we have crushers, pulverizers, drying furnaces, fire assay. These are furnaces, absorptions, spectrometers, and you can see that all type of list of equipment and the services that we provide. Quality assurance. Here, major factors are listed, which provide ensure quality. Let's move forward. Technical competency of the lab workers have been confirmed by the accreditation of the lab to meet international standards, ISO 17.25. We have local accreditation in the Kyrgyz Center for Accreditation for the Kyrgyz Republic, plus a British service, which is a UCAS accreditation for compliance with international standards, ISO IEC. We have standard ISO 17020, and over 27 years, lab was successfully providing services to our multiple partners located in Kyrgyzstan, Kazakhstan, Uzbekistan, in the Russian Federation. So these are, you see in the list, some of our clients. Thank you for your attention. I am ready to answer your questions. Thank you. Dear colleagues, we have a few minutes for Q&As. I think we can allow a few questions to be asked and answered. If any, please come to the microphone. I think everything was either very clear or not clear at all when people have no questions. Okay, let me ask a couple of questions if you're not against. Question 1 to Eric. Eric, geo support. While Eric comes to microphone, and on the slide, I saw that in Russia, in the year 16, there were 0 radars and 35 were in the next here. The dynamics very high. What about dynamics in the other countries of the world? Yes, thank you. Thank you, Ivan. Very interesting question. I don't have exact statistics on the world and global, because statistics is different. Data is different from different sources. We heard that there are more than 1,500 technical radars. I mean, 1,500 to 2,000 globally radars working, not considering China itself. China is a separate, it's a separate statistics. We think it's over 500,000. I mean, sorry, 500,000 of radars used in China. Okay, I had another question to Ivan. Ivan, I am dealing with geomechanics, so radars and all this stuff is close to me. I want to ask you a question. We are using survey from using acoustic optical survey of boreholes, of the wells, and I know there is a problem. The scanner might be torn or lost because of the unstable well. What type of protection measures do you use? Do you apply anything? What actually do you use to preserve equipment that you actually put into the boreholes?
So sometimes we lose or damage radars or devices, and what you do, and to prevent it, we recommend to apply 2 types of systems before putting the device into the bore and protect. And second option, which is widely used in Africa, particularly in so-called loose bores. We simply cover with the plastic to simply not to damage the device. Yes, my question was about PVC pipes with the diameter of digging and placing the pipes. I've heard about this technology, but I've never heard the technology is used. We never had such case, but at least the suppliers, the manufacturers provide such options. But the diameter is 42 millimeters. It's not, you don't need a large bore. Even with diameter of 76, let's say at the well, digging the well with the depth, width. Kirill, my last question to you. Could you please tell about the production lines and devices? I have seen so many pictures and photos. Some are clear, not clear. Who are your customers? Juniors, consultants, institutes? All those who you listed, they use our devices. Those juniors, archaeologists, universities, institutes, ecologists, meteorologists, or environmentalists, seismologists. So geophysics is a discipline with the widest stakeholders and they all need to use those devices. I would say service and geological companies, they use mainly our devices, and maybe universities. Universities maybe, or educational institutions. So to train students. I'm surprised, we used to apply Schroeder's with the electronic tachometer. Tachometers, those devices used to be issued, let's say, very rarely for training needs. So it's time for coffee break. Thank you so much for your patience. I'm confident that we can informally communicate or continue our dialogue. Let me announce this session is closed. Thank you.